First, I want to say thanks to the judges for giving us the chance to work on this whole semester. I'm really excited to show you what we've got so far. So last semester, we were motivated by this example of a college student, right, for example, who would cram for an exam, go into it, regurgitate what he or she just crammed, walk out of it and tell their friends that they just forgot everything that they studied. And so we wanted to provide a better educational tool by which students could learn. And so we were looking at how we've studied and techniques that we've used and others have used. And one of the techniques that we came across was a mnemonic technique called the method of Loci. And so the idea, to recap, is have a bunch of things you want to remember, create mnemonics for each one, place them in an environment that you're familiar with, walk through it in your mind, see them, and through association, recall what you want to remember. And we thought, how cool would it be if you could do this in virtual reality, right? Make this more accessible for everyone. And so what our solution was a website where users could go and create custom virtual environments, essentially making the process of this technique easier, but also making virtual reality more accessible. And to that end, we also wanted to make the learning process more fun and engaging, and to make this accessible on any virtual reality headset. And so when we were here last semester, our plan was to first start off by creating a demo environment, by building and deploying a simple web-based editor, and testing it with our partner, the Berry School. And our end goal by today would have been to validate the premise and also have a beta version of the editor up and running.
So when we thought about how best to tackle this issue, we focused on accessibility, being able to get our solution into as many hands as possible. So we saw really two main ways of going about it. We can either use Unity, which is a more fully featured platform that kind of creates applications and standalone services. Or we could use the internet and look to do web development using WebVR and the Babylon.js platform. Each one of these had their own challenges and opportunities. With Unity, we had a little bit more experience. However, we wanted to create an all-in-one solution that was also easily accessible. That means you can just go on, open your computer, your phone, whatever device, and be able to get to your virtual environment. So that really led us to go and find Babylon.js, which was an open source community platform supported by Microsoft. They've done really good work in advancing the pretty infant stage WebVR market, allowing developers to create complex environments and interactions. So we updated our roadmap to reflect the changes of the technology that we're using. Our first goal was to learn Babylon.js, figure out how we can best use it, and just start building. So we wanted to create a sample room that basically had interactions, objects, as a proof of concept. And we also wanted to make sure it was accessible to the two most widely distributed VR devices, the Google Cardboard and the Gear VR, having millions of people already have it in their hands. Our next step was to be able to deploy a web editor so people could customize their VR memory palaces themselves, being able to just put in different objects, interactions, without needing the skills to be a developer. And then finally, we wanted to do user testing and make it all work cohesively. Next.
Good job.
Oh, sorry.
So our progress was that we created the environment using the Babylon.js. We learned the collision detection and triggers. Obviously, when you're working with 3D objects and things, each of those objects, it's not so much as laying information out on a page as you would traditionally develop a website or think about an interaction. You need to think about these things as individual, almost living objects, and think about how users are going to interact with them, see them, without giving them a bad experience. So we were able to deploy our demo proof of concept scene on the Google Cardboard and Gear VR. And we were able to deploy the website using Babylon.js's open source editor that already does a lot of the heavy lifting in terms of creating these large customizable environments. So when we found Babylon.js, we really found a very early platform, only a few years old, very small, close-knit developer community, but already had a lot of the advantages and features we were already looking for. So we'll show you a simple sample demo that shows customizable objects, different room. You can see when you look at things, they can trigger. They can have multiple different triggers if you hold on to them. They can play sound. Unfortunately, we can't hear that. You can play background sound, trigger sound, being able to move objects in and out of the scene, changing objects, and so on and so forth. Also being able to navigate around the scene and being able to move around it. Next. So some of the issues we ran into was when you're building for multiple environments, how do you get the same features for each device when each device may not support those said features, right? Google Cardboard costs something like $10, while the Gear VR can cost around $100, and the price difference includes those features. But when we created the website, we wanted to have a central location that people could go to and be informed and start working on the virtual device. Do you want to?
Yeah, so in addition to, so what Mary just showed you was a lot of cool features that we thought were necessary that users might want to include in rooms. So instead of just seeing objects, you might want to bring in outside data streams, right? Because that increases the scope of what you'd be able to do with each room. And so a lot of what we did was figuring out the technology and laying the foundation for that. In addition, we deployed the open source editor, and so far what we can do is load in entire scenes. So you can load in a scene and it'll display it for you, and then you can manipulate it by adding in objects, changing any features within it, and you can export it as JavaScript code. It's not as user-friendly as you would like, but that's something we're going to be working on in the future. So overall, given that we changed technologies midway to something that we weren't very familiar with, to something that was relatively new, I think that we were able to figure out a lot. But with that said, there were some lessons that we've learned. Most importantly, I would say that we were a little ambitious with where we wanted to go last semester, and I think a part of that was because we didn't think fully through what technologies we might actually need to develop the full set of features that we wanted. And so having to change that changed our timelines towards the semester. Additionally, in terms of the readouts, initially we wanted to go to really wide and encompass as many headsets as possible. And in doing that, we forced and switched to Babylon and learned it, but that prevented us from being able to use demo rooms in one technology and get readouts for that in terms of its viability as an educational tool. Additionally, getting a demo in the hands of our partner organization, by the time we were able to get something in their hands, there were scheduling issues that prevented us from actually testing. But from here on, we've reached a point where we've figured out the technology well enough that we think that in the next few months, we are going to continue to work on the editor and add the functionality that we want to make it more user-friendly and continue to test and develop it. Thank you for your time. If you have any questions, we're happy to answer them.